Hello everyone, and welcome to question number 11 of the free machine design and materials exam offered at engineeringappliedpractice.com. Let's start with the problem statement. Question 11, a vehicle is capable of going 0 to 60 miles per hour in 2 seconds. Assume the vehicle has constant acceleration. What is the acceleration of the vehicle in meters per second squared, and how many feet does it take to get to 60 miles per hour from rest? Okay, so let's just draw what this question is asking. We have some sort of a car, and this car is capable of going 0 to 60 in 2 seconds. We can assume constant acceleration. What is the acceleration in meters per second? And how many feet does it take to get to 0 to 60 miles per hour from rest? Excuse me. Okay, so one tricky thing about this question is they've given us information in imperial units, and we're going to have to convert that to meters per second. But going back to this diagram, we see that velocity initial is going to be 0, and velocity final is going to be 60 miles per hour. So when the car is here, it's going to be 60 miles per hour. So say this is the final distance right here. So I'm going to say this is x1, and this is, say, x0. And of course, x is going in this direction. Sorry. Okay, so we want to know x1, and this will be in feet. And then we also want to know the acceleration in meters per second squared. So if you look at your reference material, there's a section for constant acceleration. And the equation that we're going to want to use here is one that looks like this. So I'm going to put equation 1. We have v as a function of time is equal to a naught t minus t naught plus v naught. Okay, and so what are we looking for in this question? We want to solve for a naught, so let's go ahead and do that. Say a naught is equal to v of t minus v naught divided by t minus t naught. Okay, so let's try to figure out if we can simplify this at all. Our goal is to get this acceleration on the left side of the equation, constant acceleration. We know velocity knots equal to 0, so we're going to say this is 0. We know that time starts at 0, so this also goes to 0. So simplifying, we're going to say acceleration is simply equal to the velocity divided by the time. And so let's move ahead with this. We know that the velocity goes from 60 miles an hour, from 0 to 60 miles an hour in 2 seconds. So we can say a naught's equal to 60 miles per hour. We're going to do some unit conversions. We know there's 1 mile in 5,280 feet. Miles cancel there. And so now we have feet per hour. We want feet per second, right? So let's say there's 1 hour per 3,600 seconds. Hours cancel, so now we're looking in the numerator here. We're going to be looking at feet per second, which sounds like a good unit to me. So on the bottom, we know that it can accomplish this in 2 seconds. So let's just write 2 seconds. And so that looks like the correct units. We're going to get feet per second squared. So let's calculate this. We're going to get 44 feet per second squared. So that's our acceleration in imperial units. However, the question is asking for metric units. So let's simply do some unit conversion. I'm going to draw a line here, not to get confused. Times 0.3048 meters per foot. Feet cancel. And we're going to get 13.41 meters per second squared. And looking at the answer selection, there's only one there, which is B. So that's great. But let's go ahead and finish the problem and make sure we're on the right track. So the last part of the problem is that we need to calculate how many feet it takes to get to that velocity. And it wants it in feet. And we're going to be looking for 88 feet. So let's do a new page here. And looking at the reference material, again, we can find an equation to use. So I'm going to put equation 2, and it's equal to v squared. It's equal to v naught squared plus 2 constant acceleration s minus s naught. Let's simplify this equation right now. We know we're starting at x is equal to 0. So in this case, that would be the s. Initial position is just 0. We also know that the initial velocity is 0. Okay, and then we want to solve for s. So I'll do it in a few steps here. And we want to solve for s. So s is equal to v squared over 2 a naught. And so all we have to do here is plug in. So we can say s is equal to the velocity. So let's do the unit conversion again. We can say 60 miles per hour times 5280 feet per mile. And so we get miles cancel off. And then we can say that there is 1 hour per 3600 seconds. This is the velocity. This is squared. And then 2 times the acceleration. And the acceleration that we got was 44 feet per second squared. Let's make sure the units make sense. We have in the top the hours canceled, so we have feet per second. It gets squared, so feet squared per second squared, and then feet per second squared on the bottom. So let's break it down. Feet squared per second squared divided by feet per second squared. That cancels, and we're left with feet. So units make sense. It's good. Plugging in, looks like we're going to get that 88 feet. Yes. Okay, so that indeed is the correct distance. So for this question, the answer is B. If you have any comments or questions, leave them below. Thank you very much, and goodbye.